Welcome to General Physics 1. So in this video, we're going to continue our discussion on the forces acting on an inclined plane. So here, we're going to integrate the inclined plane with the pulley system. So let's try answering this problem. A 20 kilogram crate, our mass 1, rests on an inclined plane and is connected by a cable to a 40 kilogram mass, so our mass 2. The second mass is suspended over a pulley. The inclined angle is 35 degrees and the surface is frictionless. Determine A. Net force acting on the system. B. The total mass of the system. C. The acceleration of the system. And D. The tension in the cable. So take note that in this problem, we assume that the inclined plane and our pulley system or our pulley is frictionless. So the pulley and in surface is frictionless. And we also assume that the pulley and the cable is massless. So in this scenario where this is frictionless and massless, it would make solving the problem much easier. So yun. So frictionless muna tayo. Frictionless situations. So let us now try answering our problem. So step number 1, of course, is to create a diagram. So here we have a diagram. And then identify the forces that is acting on the body. So label and then identify the forces. Draw a diagram. Wait lang. Okay, so we have here our mass 1 that is resting on our inclined plane. So ito yung mass 1 and then this is mass 2 which is suspended on over a pulley. So yan. So mass 1 and mass 2 are connected by a massless string. So therefore, itong string na to will experience a tension force. So yung mass 1 pala natin, mass 1 is equal to 20 kilograms and mass 2 is equal to 40 kilograms. So this inclined plane is has an angle of 35 degrees. In answering this problem, so letter A, so we're looking for the net force. So to determine the net force, it is much easier to treat this system as to treat these masses, so this situation as a one system, so isang system. So therefore, yung tension dito and then tension force dyan, hindi na natin isasama dito sa net force that is acting on the system. Because since we treat this as a system, yung tension forces, since nag-act siya dito sa string and the string is part of this system, therefore, yung tension force natin dito is an internal force of our system. So, ang gusto nating malaman, ano yung force that will act on these two masses. So, since they have a mass, so the only force that will act to these masses is the force due to gravity. So, tanggalin muna natin si tension force dito. So the only force that will act on these two bodies, two masses, is the force due to gravity. So for mass number 2, the force due to gravity is directed straight downwards because this is hanging vertically in a pulley over a pulley. So yan yung ating mass number 2, the force that is acting on mass number 2, external force to be exact. Yan, which is equal to mass 2 times the acceleration due to gravity. For mass number 1, we have here also the force due to gravity. But since this is sitting on an incline, we resolve the force to its x component. This is the x component and the y component. So our y component here is cancelled by the normal force. So therefore, So y component will neglect y component in this situation because it will be cancelled out by the normal force. So therefore, the force that is the external force that is acting on mass number 1 is the force due to gravity, the x component of the force due to gravity. So now that we have identified the two external forces that is acting on our system, yan yung two external forces, we can now solve for the net force. So we know that the net force is the sum of the forces. So if we have two forces, force number 1 plus force number 2. So now we now know if whether we need to add or we need to subtract. So these masses have different values. So the first one, mass 1 is 20 kilograms and mass 2 is 40 kilograms. If we solve for the weight of these masses, yung natin, mass 2 will have a greater value of weight. So this will be heavier compared to mass number 1. So since this is heavier, we can assume that the direction of the motion or the direction of the acceleration is towards this direction. So this system will be accelerating towards this direction because this mass number 2 is heavier compared to mass number 1. So if mass number 1 is heavier, then the system will be accelerating this way. But since mass number 2 is heavier compared to mass 1, the system is accelerating this way. So we consider the direction of the acceleration to be positive. So the direction of the acceleration to be positive, therefore the force that is causing this acceleration is our positive force. While this force that is opposing the direction of our acceleration, so the force that is opposing this this acceleration, direction of acceleration, will be considered as our negative, directed negative. So therefore, if our force number 1 is this the weight of mass 2 and our force number 2 is the x component of the force due to gravity acting on mass 1, then net force is equal to Fg of mass number 2 and plus negative Fg of x. So we know, since we know that Fg of x is equal to Fg sine theta, and then Fg is simply mass times the gravitational acceleration sine theta. And this one, since this is for mass 1, so this, we include here mass 1. So we can use this equation instead of this term. So we can substitute this and plug it here. So yung mass number, naman natin, yung weight number 2 natin. So ito, we know that force due to gravity is equal to mass times acceleration due to gravity. So since this is mass 2, we're going to use mass 2. So dito, pwede natin tong palitan ng m2g kasi ang given natin is mass. So hindi given yung weight. So therefore, we need to solve for the value of the weight or the value of the force due to gravity. So since this is negative, so instead of plus, we subtract. And i-plug in natin tong m1g sine theta. Mass 1 times acceleration due to gravity sine theta. Okay, so since we have now our equation for the net force, so we can now substitute this with the given value. So our mass 1, so I will drop the units kasi hindi kakasya dito. So mass 1, ay mass number 2 is 40 kilograms times 9.8 meter per second squared minus 20 kilograms mass 1 times 9.8 meter per second squared sine, and our given angle is 35 degrees. So sine 35 degrees. 40 times 9.8 is 392 newtons minus 20 kilograms times 9.8 meter per second squared is equal to 196 newtons sine 35 degrees. 392 newtons minus, so 196 newtons sine 35 degrees, i-plug nyo sa, enter nyo sa calculator nyo, you will get 112 newtons. So, approximately 112 newtons. So, the net force now is equal to 280 newtons. So, this is the external force, the net external force that is acting on this system. And this force is causing our object to accelerate to this direction. Okay, so for letter B, nawala na yung natin diagram. Excuse me. Okay lang yan. So, letter B, we need to look for the total mass. Symbol niya is MT. So, total mass natin is equal to mass 1 plus mass 2, and if there are other masses, mass 3 plus mass 4, and so on. But since in this scenario, in this situation, we only have two masses, mass 1 and mass 2. So, where mass 1 is equal to 20 kilogram and mass 2 is equal to 40 kilogram. So, we consider the pulley and our, cable to be massless. So, therefore, we only have this 20 kilogram and 40 kilogram. So, therefore, to solve for the total mass, we just add 20 kilogram for mass 1 plus 40 kilogram. So, mass 2. So, 20 plus 40, our total mass now is equal to 60 kilogram. So, this is the total mass of our system, 60 kilogram. Problem number 3, letter C. So, letter C is to look for the acceleration of the system. So, to look for the acceleration of the system, we use Newton's second law. So, according to second law, force or net force is equal to mass times acceleration. And to look for acceleration, we derive from this equation to get acceleration is equal to net force divided by the mass. So, since we are treating this situation, these bodies, as one system, so therefore, instead of a single mass, we get the total mass. So, we have the value for the net force. So, from our solution in part A, so F net is equal to 280 newtons. And our total mass is equal to 60 kilograms. So, we can now substitute our equation with our calculated value. So, F net is 280 newtons and our total mass is 60 kilograms. 280 divided by 60 kilograms will result to 4.66666, and round it off, we have 4.67 meter per second squared kasi maka-cancel out si kilogram. So, our body, our system, so this is mass 2, this is mass 1. So, sabi natin that this system is accelerating to this direction. So, the value, so our system is accelerating at a rate of 4.67 meter per second squared. So, this is the acceleration of our system. So, now that we have the value for our acceleration, we can now use this to solve for the tension acting on our string, our cord. So, letter D is to find the tension on the cable. So here we know that this part here, so this string is holding this object, so therefore this string will be exerting, it will be experiencing a force, or will be having a tension force to support this body, and this one will also support this from sliding. So therefore this part of the string will also have a tension. So let's call this, since this is mass 1, let's call this tension 1. Since this is mass 2, let us call this tension force number 2. So since we assume that this string is massless, tension 1 must be equal to tension number 2. So to solve for the tension forces, we need to treat this as an individual system. So we're going to look into the forces that is acting to this part of our system, and the forces that is acting on this system. So hiwalay natin siya. We'll treat them as an individual and separate system. So kapag sinolve natin yung value ni T1, yung value ni tension 1 dito is equal to tension number 2. But to prove that they are equal, let us show the solution for both tensions 1 and tension 2. So let us start with mass number 1. So tension number 1. Solving for tension 1. So here, so sabi natin, this mass will be acted upon by the force due to gravity, and we already resolved the forces to the y component, Fg of y, and to the x component, Fg of x. So y component will be cancelled out by the normal force. So therefore, the forces that we need to consider to solve for the tension force is this one. So the force due to the x component of the force due to gravity. So since mass 1 is accelerating upwards, because we already know that this system will be accelerating towards this direction because this is heavier. So therefore, since mass 1 is accelerating towards this direction, we treat the forces acting towards this direction to be positive, and the opposing force to be negative. So the sum of forces, so since this is our x-axis, the sum of forces along our x-axis is equal to tension 1 minus our x component of the force due to gravity. So we know that Fg of x is equal to Fg sine theta, and Fg is, since this is mass 1, so mass 1 times the acceleration due to gravity sine theta. So we can substitute this with this value. So yan. So mamaya na natin palitan. So let us solve first for kasi ang hinahanap natin si tension 1, di ba? Hinahanap natin si tension 1. So therefore, ilipat natin tawag nga dito. Ilipat natin tong the force due to gravity, the x component of the force due to gravity dun sa kabila. So the tension 1 is equal to summation of forces along the x minus or plus, since negative siya dito, magiging plus siya sa kabila, Fg of x. And then we know that Fg of x is m1 g sine theta, and then the summation or the net force, sabi natin from second law, that the net force is equal to mass 1 ay mass times acceleration. So yung mass natin dito is mass number 1. Yan. So mass natin dyan is mass number 1 because these are the forces acting to mass 1, diba? So yon. So therefore we can substitute this to this and this one to our x component of force due to gravity. So tension 1 now is equal to excuse me, m1 times acceleration plus m1 times acceleration due to gravity sine theta. So we have the value for the acceleration. So from our solution C, dun sa kanina nating answer, asa na yun? Okay. So itong sagot natin dito, so yung acceleration natin is 4.67 meter per second squared. So the acceleration of our system, so ilagay natin dito that A is equal to 4.67 meter per second squared. And mass 1 is equal to 20 kilograms. So we can substitute this to this equation. And again, the angle is 35 degrees. So here, mass 1 is 20 times 9. Hindi siya 9.8. So acceleration of the system, 4.67 meter per second squared plus 20 times 9.8 sine 35 degrees. 20 times 4.67, ano ba yung value nun? 20 times 4.67 is equal to 93.4 Newton plus 20 times 9.8 is 196 Newton sine 35. So 196 Newton sine 35 is equal to 112. Asa na yun? Approximately 112.4 Newton. Okay, so 93.4 Newton plus 112.4 is equal to 205.8 Newton, or approximately 206 Newton. So the tension force that is acting on this string is equal to 206 Newton. So since sabi natin tension 1 is equal to tension 2, we can say that tension 1 is 206 Newton and then tension 2 is also 206 Newton. But let us prove that they are equal. So at least dapat yung value ni tension number 2, kapag sinolve natin siya, dapat close siya sa value ni tension 1. If not equal, dapat close yung value to the value of tension 1. So let us saan na yun? So let us solve for tension number 2. So again, so this system is accelerating towards this direction, diba? And this is mass number 2. We have here tension 2. So the force that is acting on our mass number 2 is tension 2 that is holding this, supporting this mass, and the force due to gravity, which is equal to mass 2 times the acceleration due to gravity. So since this is accelerating towards this direction, we treat the downward force to be positive because this is the direction of the acceleration, and the opposing force to be the negative. So therefore, our upward force here is negative because it is opposite to the direction of the motion or the direction of the acceleration. So the summation of force along y-axis is equal to, so this is for tension 2, solving for tension 2. And again, sabi natin, tension 1 is equal to tension 2. So kanina nakuha natin, so this is 206 Newton, approximately 206 Newton. So ano yung value ni tension 2? So dapat close siya sa 206. So summation of forces along the y, we have Fg, or the weight of mass 2 minus tension 2. Okay, minus tension number 2. Okay, so to look for the solution for tension number 2, let us derive. So, ilipat natin si tension number 2 sa other side of the equation, and then ilipat natin itong net force, masonry forces along y sa kabilang side ng equation. So, since ito ay negative dito sa side, pag linipat natin dito, magiging positive siya, equals to Fg minus, kasi positive dito, so minus the summation of forces along y. So, yung Fg natin is equal to m2 times g, or the acceleration due to gravity. And thus, the summation of forces along y is net force yan, diba? So, EFY is equal to net force along this axis. And we know that from second law of motion, net force is equal to mass times acceleration. So, since this is mass 2, ilagay natin dyan, mass 2 times acceleration. So, we can substitute this to this one and this one to this one. So, palitan natin sila. So, that tension number 2 is equal to M2G minus M2A. So, the value ng mass number 2 natin is equal to 40 kilograms. At yung ang tawag dito, ano nga yun? Yung acceleration of the system is equal to 4.67 meter per second squared. So, palitan natin ng value itong equation natin. So, M2, 40 times 9.8 meter per second squared minus 40 kilograms times 4.67 meter per second squared. 40 times 9.8 is equal to 392 newtons. And then, 40 times 4.67 is approximately 186 newtons. 392 minus newtons minus 186 newtons is equal to, yung tension number 2 natin is 206 newtons. So, tension 1 is equal to tension number 2. So, the tension that is experienced by the cord, so itong tension dito sa string na to, is equal to 206 newtons. So, ang final answer natin ngayon is that, yun na, yung apat natin. So, the tension experienced by the string is 206 newtons. The acceleration of the system is 4.67 meter per second squared. The total mass of the system is 60 kilograms, and for letter A, the net force acting on the system is 280 newtons. So, I hope that these problems or these examples, example 1 and example 2, help you to understand how to analyze problems involving inclined planes and inclined planes that is incorporated or integrated with the pulley system. So, in our next video, we're going to discuss friction forces. So, in all of our examples from the flat surface to this inclined plane, we'll try to solve the forces acting on a body, trying to mix friction force in the calculation, in the equation. So, see you in our next video.